Okay, so today we'll start here. Case 5, quadrantal triangle now. There is a too much similarity between the problems of right angle triangle and a quadrantal triangle. Now, anyone knows the definition of a quadrantal triangle? What is the meaning of quadrantal triangle? Any idea? We know the word quadrant. Quadrant means, yes, it is a 1/4 part of the plane, that is a quadrant. Indirectly, it is up to 90 degree again. Okay, so quadrantal triangle is a triangle in which one of the side is of a 90 degree. If any one side of a triangle is a 90 degree, that triangle is known as a quadrantal triangle. So here is one example. You'll observe the side C, this small c is a 90 degree, it is opposite to the capital C there. So this triangle is a quadrantal triangle now because length AB is a 90 degree. Okay, that's one. So whenever we have quadrantal triangle or a right angle triangle, both the problems are solved by the same Napier's rule only. Okay, only the small difference is there, and that difference is in a Napier circle. In Napier circle, there is a very small difference that will come to know when I draw it. So let me draw the Napier circle first. So to draw first draw a circle. Step number 1, draw a circle. Suppose this is our circle. Divide this circle into 5 equal parts. So if I divide this way, give the numbers to the circle, this part 1 as 1 to 5. So 1, 2, 3, 4 and 5. Now can you guess what should be in the part 1 and 2?
Sir, small a and b.
No, not correct.
Sir, angle A and B.
Angle A and B. So it is just like a right angle triangle. In right angle triangle, we take adjacent sides of that 90 degree. Here also we'll take adjacent angles of a 90 degree side now. So capital A and B is a correct answer. So put capital A and capital B in the adjacent, that part 1 and 2, which are the adjacent angles of the 90 degree side. Okay. Then what should be in the part 3 now?
So 90 minus small a.
Yes, correct. It is a complement of the opposite side. And similarly in part 5,
90 minus B.
90 minus small b, correct. Now only there is a small difference in the part 4, and can anyone guess what should be that difference? Or what should be in the part 4 now?
C minus 90.
C minus 90, that's a correct answer. Very good. So we have to take now opposite angle to that side, that is capital C. Generally we write there 90 minus C only in right angle triangle, but here is a C minus 90. So this capital C is angle minus 90. So this is mainly the difference. This is a very important difference. Remember, should not make a silly mistake in writing the part 4, because this part 4 is mainly the different in right angled and quadrantal. If it is a quadrantal, right angle triangle, there is a 90 minus small c there. Okay, that way. So you can see that previous session there. So otherwise now everything is similar. Only this part 4 is written in a different way. The Napier rule is the same. Okay. And in the same way we can proceed and we can solve our ambiguity with same affection criteria. Okay, so all that things are similar here, nothing different. Only because of this C minus 90, we come across 3 formulas. First of all, sine of this say C minus 90. Can anyone guess what should be the answer? Sine C minus 90, what should be the simplification? Is it cos C or something else? Minus cos C is the correct answer, because first of all we should write it as a 90 minus theta form. So if you take minus common, sine of minus theta is a minus sine theta. So this can be written as a minus sine of 90 minus C, minus this is a sine of 90 minus C, and sine 90 minus theta is a cos theta, so minus cos C. Sine of C minus 90 is minus cos C. So this sign is also important when you do a calculation. Otherwise, your angle completely changes and you get wrong solution. So sin C minus 90, similarly, we require cos C minus 90. Yes, anyone guess? What should be cos C minus 90?
Sin theta.
Sin C only, correct.
Minus
Very good.
sin C.
Not minus sin C, it is a plus. Because cos of 90 minus theta, see, when you take minus common, cos of minus theta is a plus cos theta only. Cos of minus theta is cos. So cos of C minus 90 is a sin C, or cos of 90 minus C is also sin C. Are you getting? And the last, tan of, C minus 90. C minus 90. It is a minus
Minus.
cot C. Okay, so that are the three new formulas that you should remember. Otherwise, everything is similar there. Any doubt up to here?
No, sir.
No. Okay, good. So let I show you these things one by one. So first we have to draw this Napier circle only. Draw a circle, divide it into the 5 parts. This part 1 and 2. Part 1 and 2 have the angle containing the quadrant side. Then they complement in the opposite parts, and this is a C minus 90, that is a opposite angle minus 90, that should be in the part 4. That is, everything is written here, and you will observe. So this is the main part, capital C minus 90. This is 90 minus B, 90 minus A, capital A B. So these are similar. So this way also you can draw your Napier circle. Okay. That about the Napier circle. Now Napier's rule. Yes, they are not new. They are same now. We already learnt. Sine of the middle part is a product of cosine of opposite parts. So sine of middle part is a product of cos of opposite, or sine of middle part is a product of tan of adjacents. Okay, tan of adjacent. That rule we use and we solve that problem. So we should have in right angle quadrantal spherical triangle, either exactly two angles are of 90 degree. So whenever one side is quadrantal, so if it is a quadrantal, okay, in right quadrantal spherical triangle. So sometimes this word right is used without right also. If you say in quadrantal triangle, that is also right only. Okay, because when we say either exactly two angles are of 90 degree or three greater than 90 degree. Okay, means a right angled plus quadrantal. If the triangle is right angled as well as quadrantal, then the two angles, exactly two angles, should be less than 90. No, 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 no. I'm again this right quadrantal means only quadrantal. It is related to the quadrantal. Okay, my mistake. So this is a quadrantal triangle which have one side as a 90 degree. Then in such a quadrantal triangle, either two angles should be less than 90 degree or all three should greater than 90. That is one of the property. No need to by heart, not required. But yes, same affection criteria will use to solve the ambiguity created by a sine function. And lastly, this formula is sine theta minus 90 is a minus cos theta. Cos theta minus 90 is a plus sine theta, and tan theta minus 90 is a minus cot theta. Okay, so that about the important things that we already discussed. Okay, now the question only. We'll move to the example, becomes more clear. So question is, in a spherical triangle PQR, PQ is a, now see the notations. Here the notations of small alphabets or lowercase are not used. So sometimes the question may ask in this form also. Okay. So we are given PQ as a 52 degree 11 minute, Q as 69 degree 47, but QR, one of the side is given as a 90 degree, so it is a quadrantal triangle, and we have to find out the remaining three missing components there. The remaining three missing components. Now see the diagram first. So here's the diagram we drawn. So where we said we are given capital Q 69 degree 47 minute, small p, that is a QR, is given as 90 degree, small r is given, and now question is capital P. Okay, this is a small q and capital R. That three things we have to calculate. So here is a Napier circle. In Napier circle, let I give the names there, numbers. So say this is a 1 and 2. So in 1 and 2, we replace the adjacent angles of the quadrantal side. So capital QR. Then in up, this is a 3, 4, and 5. In part 5, we, so here is X is by mistake I written. It should be, yes, 90 minus
Sir, R.
small r. So it should be 90 minus small r, and this is 90 minus small q, and it is a p minus 90. Okay, this is actually a capital P minus 90. So you should not confuse between capital and small. So this way. So that way our Napier circle will look. Now, important thing, once we draw a Napier circle and we put all these angles, you should just tick mark which parts we are available. Small p is available. So where is a small p in this? Or I made a mistake here. Is it correct? My mistake actually. Somewhere I made a mistake. So is it small p only there?
Sir, small p is given.
Given. Yes, given. But in this
No, sir, it's
So we
capital.
are
sorry,
given
sorry, so
90
capital P.
minus R
Sorry,
and
sorry.
capital P.
Yeah, my mistake. Yeah, small p is given. It is a 90-degree only. Correct. It is capital P only. Okay, small capital Q is given. So part one is given. Okay, so this part one is already known to us. Capital Q, small r is also known. So part five. So 1 and 5 are known, and now 2, 3, 4 are missing. That we have to compute. So tell me which formula you will use to get one of the quantity. Capital R, small q, capital P. So which formula we should use? I'm asking about Napier's rule. Which Napier rule you will use? Middle part is equal to cos of opposite, or middle part is equal to tan of opposite? And
10.
okay,
And
tan. And which should be the middle part then?
90 minus Q.
90 minus q. If you said tan, so if this is middle part, the sine of middle part is equal to tan of adjacent. Then you will get
Sir,
this one,
cos.
na? So it should be cos. Okay, obvious
sir,
thing is there. So you cannot use a tan because tan gives and all three are unknown to us. So it's of no use at all. So step number one, we should use sine of middle part, and that middle part is taken as a part 3.
R.
Okay, part 3, and it is a cos of opposite. So cos of 1 and cos of 5.
5.
Okay, so this rule we can use it, and we get after this rule, the part 3 will known to us. This part 3, we can find out a part 3 with the help of this Napier's rule. Then we'll have this part 3 also. This will also be available. Now after that, which rule you should use?
So sine
Sir,
4 is
sine
equal to
capital.
10, 3 into 10, 5.
Sine of which part?
10 sine 4.
Okay, sine 4. Okay, so you started with the sine 4. Sine 4 is
Tan 3 into 10, 5.
tan 3 into, okay, that way also that's correct. Tan 3, tan of 5, and this way we get the part 4. So part 4 will be available after that, and lastly part 2 can be calculated with any of the formula, but yes, which formula we'll use for part 2?
So sine of part 2 is equals to cos of 5 into cos of 4.
Sine of part 2 is equal to cos of 5 and cos of 4. Okay, that is one way. Or if you're not happy with the cosine, you can use a tan also, tan of 1 and tan of 3 also. But in which case the ambiguity will create? Case 1, 2, or 3. In which case you will get the ambiguity with a sine function? First, second, or third? When you calculate part 3, part 4, or part 2, in which part calculation you will get the ambiguity? See,
4.
Yeah, no, not correct. Part 2, when you calculate part 2, you will create ambiguity. That is the correct answer. You will see here. In part 3 calculation, we have sine of 3. Sine of 3 means sine 90 minus theta become cos q. So it become cos q and it doesn't have an ambiguity because cos q is equal to cos inverse. And cos inverse gives us a unique answer. When you calculate a part 4, this part 4, we have sine of a fourth part, that is sine of capital P minus 90. Okay, so you can convert this as a minus cos P. It is a minus cos P, and again it is a that minus sign you can shift on the RHS and P become a cos inverse. So again it gives us a unique answer. So you will have unique answers for these two. But when you calculate this part 4, you get sine of R only, and that R becomes a sine inverse. And when you have sine inverse, you have to write down the two answers. One is a theta and another is a 180 minus theta. Theta and 180 minus theta, and you can take the proper angle, you select the correct angle by a same affection criteria. So we'll see a complete solution now one by one here. So here first I started with to get the value of a capital P. This is capital P. Okay, there is my mistake. It is the notations are not correct there in diagram, but should draw it correctly. So this way you will calculate and you will get the answer for. So different ways are there. Choice is your. So right now it is converted into tan, and then it is calculated with the tan this side. So tan inverse way, that also you can get it, but the answer will be same. The answer will be same. Now here the problem is created. This problem is created because of a tan inverse. Remember, when you take a tan inverse also gives us two angles. I think no, not two angle. So tan inverse of so it is taken as a P minus 90 is a tan inverse. Then 90 is added, and you got that answer there. So this is one of the way. Other way, yes, just we seen before. So you just use a sign there, sine and cosine. That's better. Okay, but here are the answers. Here are the answers. So this is alternative way. Choice is your. You can go by any of the way. Okay, because already we discuss about this Napier circle. In Napier circle, we take sine of a middle part and we can select any one of the part as a middle part. So there are 10 total formulas which can be created with a Napier's rule. Okay, 5 with each rule, 5 formulae with each rule. There are 2 rules. So total 10 formulas we can create, and everyone have their own choice to use the formula out of that 10 formula. But your answer is a unique there. You cannot say I have the different answer. Here is capital R. Okay, this is capital R. And lastly this PR. So right now the formulas are used so that this sine inverse not appeared anywhere. As sine inverse not appeared anywhere, the ambiguity is not created. There is no ambiguity. Why the ambiguity is not there? Because the formula is selected so that you will not get sine inverse of this P or sine inverse of R or sine inverse of that small p. So nowhere sine inverse appeared in the calculation. Hence, there is no ambiguity occurred, and there is no need to use the same affection criteria. But by chance, if you use just we seen, if you use capital R as a middle part, okay, and these are opposite or adjacent, then you get sine of capital R, and that R becomes a sine inverse. So that time you have to use same affection criteria there. Any doubt? Is there a doubt? I know definitely this practice is required on paper, and I will give the already I told I will give the assignment or this tutorial on this. So that time you will go through these formulas and your calculations, and then we will discuss about their solutions also. Now there is one special case in quadrantal triangle and right angle triangle mainly, where only this is a special case where you will have more than one solution to the spherical triangle. Right now in each first 8 example, we completed 8 examples up to here. These examples we solved by cosine rule, sine rule, Okay, mainly cosine rule, sine rule, and this Napier's rule. So these are the three main rules that mainly we utilized everywhere, and we solved that. Yes, others are also there like Haber sign, but it is optional, I said. So in all 8 examples, whatever the answers we are getting, they are unique answers. So whenever there are more than one angles are coming by sine inverse, we are saying we should select one angle only a by the same affection criteria, or this larger side should have larger angle opposite to it, that property, that way. But there is only one case where we have more than one solution. So there will be two possible triangles in that situation. Only in that situation, let I show you that situation. So here is that situation. So what is that situation? When we have right angled spherical triangle, first of all, it should be a right angled spherical triangle. And in that right angled spherical triangle, we are given a side and opposite angle only. Side and opposite angle. So here one triangle is shown, L and M. Okay, LMN. Okay, so LMN is a right angled spherical triangle where L is a 90 degree. L is a 90 degree. Suppose in this triangle we are given capital N and small n. Capital N and small n. And we have to calculate capital M, small m, and L. Let I write it here, then it becomes more clear. And that there are two cases. Most important thing, it should be a right angle triangle. So this is the 90 degree. And we suppose we are given this small n and capital N are given. They are given. Small n and capital N. They are given. And we have to find out, and the question is find this capital M, small m, and L. Suppose this is the question. Or instead of giving the pair of this side and angle, if we are given the pair of this given capital M and small m, capital M and small m, and the question is find that capital N, small n, and L. So in both these cases, we have two solutions. Why that two solutions there? You will come to know that when we find out capital M and small m, capital M and small m, and we come across that sine inverse, and sine inverse gives us a two angle. And when we get a two angles for sine inverse, we solve that ambiguity by same affection criteria. And what same affection criteria says, if opposite angle is less than 90, if angle is less than 90, side should be less than 90. But right now both are unknown to us. Capital M is also unknown to us, small m is also unknown to us, or suppose capital N and small n both are unknown to us, then we cannot use the same affection criteria. As we cannot use the same affection criteria, we should say there are both the solutions. Both the solutions, you have to write it. Just write sine inverse and both the angles you have to write it. Like one is a theta and another is a 180 minus theta. So that are the two, and there will be a two triangle. One triangle, this one triangle is here. This is the first triangle, and there is another triangle on the downside. So there are two possible triangles there on the surface of the sphere, and we have two solutions there. Okay, one solution for the lower triangle and other solution is for upper triangle. So here is that only one solved example in the textbook also. Okay, you will find this solved example, and this only the question asked one or twice in old question paper. So only one question is here in there. But remember, what is the case? The case is in right angle triangle, a pair of angle and opposite side is given. Right angle triangle and angle and opposite side is given. Then there are two solutions. So this thing you should remember as a special case of a spherical triangle there. We'll discuss about these two solutions. First of all, we have to create the Napier's circle. In Napier's circle, we given the number 1, 2, 3, 4, and 5. So these numbers given to the sector or this yes, part of the circles, and we replace as capital L is a 90 degree, adjacent sides, which is a small m and small n, are replaced in the part 1 and 2. Okay, adjacent sides of a 90 degree replaced there. So 90 minus capital N, 90 minus capital M, and here it should be 90 minus L because it is a right angle triangle. Okay, otherwise it is a L minus 90 will be there in quadrantal there. So that way. Now just will highlight which things are known to us. Which things are known to us. Out of these, yes, we are given capital M is given. So capital M is given means part 3 is given. Part 3 given. Capital L is given. Okay, but it is not in the Napier's circle there. And small m is given means part 1 is given. And we have to find out the remaining 3. Remaining 3. Now tell me which rule you will use first. Which rule you will use to get one of the component? Yes, anyone quick?
So sine 2 is equals to
Sine
tan
2,
of 1
yes.
into sine of.
Sine of 2
Cosine of 5.
is equal to the cosine will not work because these are unknown to us. Cos
So tan
opposite
of
tan
1
only.
and 2.
Tan of adjacent. Tan of 1 into tan of 3. Now in this case, with this formula actually we'll calculate a part 2. Means small n will calculate. The small n. Remember, when you use this formula, you'll get sine of n, and you'll get n equal to sine inverse of that. When you get n equal to sine inverse, you have to write down both the angles, theta and 1 minus theta. You should say theta and 1 minus theta will be the answer. And you have to keep both the answers as highlighted there. Okay. So that about part 2. You cannot solve the ambiguity there. You cannot solve the ambiguity in right angle triangle when the pair of opposite side and angle is a given that way. So either this 1 and 3 given or sometimes 2 and 5 given that way. That time the ambiguity is there. After this, yes, which rule you will use? You should be more careful now because this part 2 have two answers. There are two answers for the part 2. So you should keep in mind. Where 1 and 3 have only one answer. 1 and 3 have only one angles there. So which rule you will use? Tell me. Yes, anyone?
So sine 3, cos
Okay.
1, and cos 5.
Cos 1 and cos 5. So sine of 3, okay, good. And these are opposite. Very good. You see, he's cleverly selected these sectors so that avoided the 2. Why it is avoided 2? Because if we want to use the sector 2, the problem is we have to do two different calculation with two angles. So you have to say case 1 when theta, case 2 180 minus theta, and you have to use that. So instead, whatever he said, that is a very good answer. That is a sine of third part, sine of a part 3, which is cos of opposite, which is a cos of 1 and cos of cos of 5. Now out of these, remember this sine 3 is known to us, cos 1 is also known to us. Okay, cos 5, actually cos of 90 minus n becomes sin n. And again this gives us a two answers. Actually this will be used to compute capital N. We use to compute, actually this is part 5. And here also we'll get two solutions. So then we got two solutions there. Two solutions we got. Or two answers we got for capital N that way. Is that clear?
Yes, sir.
Now only the part 4 is left. Now how you will handle now? Check.
Sir, sine of 1 is equals to cos of 4 and cos of 3.
Nice, good. So that again the two solution that two angles solution is avoided, and this is also the very good answer. So you should say sine of 1 is cos of 4 and cos of 3. That's a good answer. Okay, and that time also you will get this is a missing actually, and this is cos converted in sine, and again you get two solutions for part 4. Is that clear? And then you have to, at the end, you have to sum up the answers. That first we will come to that detailed solutions here. Okay, so this is nicely. Remember, it is not necessary that you should avoid only this part 2, part 5 or part 4 there. But if you want to use that part 2 in a solution, then you have to do the two calculations there. You have to do the two calculation with one calculation with angle theta and another calculation with the angle 180 minus theta. That's only the difference there. So here is a detailed solution now. So this is the same question that we seen in the previous slide. You'll observe first we are calculating this uh, sine of m. Okay, so one is selected as a middle part, and then this 4 and 3 are selected as a opposite part, and we get two angles. You'll observe one angle is a theta, one is a theta, and another is a 180 minus theta. So this is the theta and another is 180 minus theta. So that about the angle L, that is part 4. Part 4 have the two solutions, and you cannot solve the ambiguity. Remember, this is the difference only. Here don't say that L should be 65 only or L should be 114 only. That is not possible. This is a special case of a spherical triangle. You got two answers for capital N also, and you got two answers for small n also. So at the end, we can say the answers are L is this one or this one, N is also this one or this one, and N is also this one or this one. So all LMN have two different solutions there. Got it? Any doubt?
No, sir.
No doubt. Okay, good. So that about your case case 4 or 5, I think. That is a quadrantal triangle there. Okay, quadrantal triangle.